In this video, I'd like to take a look at linkage. Linkage involves two genes rather than just one. Now, we've already had one video where we looked at two genes, and that was the one where we had a case of independent assortment, and the genes were on different homologs. In that example, we had a chromosome that had a particular gene on it. We'll call it the gene A, and another chromosome, which I'm showing differently as being a wavy chromosome. What am I doing here? Sorry. The straight chromosome had the A locus on it, and the wavy chromosome had, for instance, the B locus on it. That was a situation where we could show independent assortment, which was Mendel's second law. So that was in a previous lecture. What if, though, the A and the B gene are on the same chromosome? That's what we're talking about with linkage. So in that case, we have a chromosome with its two homologs, and it has both genes on it. It has the A locus, and it also has the B locus. That's called linkage. And these are the linked genes. They're physically connected because they're on the same chromosome. And you can see with this probably that these genes are not going to be able to independently assort because they're on the same chromosome. In the previous example, they could independently assort because they were on different chromosomes, and the homologs would separate independently. But in this case, they're on the same one. So what happens? Well, let's replicate these chromosomes. So they're going into meiosis, and I'm showing the sister chromatids. I got to make a little room though. Let's make this the recessive. Okay, so now we have them replicated, and if we can fast forward to the gamete production, then we're going to have, from this homolog, two gametes produced that are both identical. So those are the two gametes, big A, big B in both cases, that are going to come from this homolog. And this homolog is going to result in two other types of gametes. That are little a and little b. All right, so you see that because the genes are linked, then the alleles on that particular sister chromatid are moving together because they're physically linked to a gamete. So here we have big A, big B, and that's what we find in the gamete. Big A, big B here, that's what we find in the gamete. Little a, little b here, that's what we find in the gamete. Little a, little b here, we find that in the gamete. Okay, so that's the case of linkage, where we don't get independent assortment. However, you can have recombination. There are situations where even though genes are linked, you can have other types of gametes as a result of recombination through crossing over. And you heard about crossing over already when we looked at the mechanics of meiosis. So here's what could happen. Same genes, I'm just going to redraw it. Here's one sister chromatid, big A, big B. Here's the other sister chromatid. Here's where it gets interesting. Centromere. And then you'll see this in a minute. And now I'm going to do the other homolog. So here we have big A. Here we have little a, little a. Here we have little b, big B. What's happened is that this sister chromatid over here crossed over the sister chromatid from the other homolog. So they crossed. And so instead of being lined up here straight, it's now over on with the other homolog. This is a crossover event. So you get breakage, repair, and after crossover it looks like this. And so we've had recombination. Now the gametes are different. In fact, all 4 gametes are different. One is going to have the big A and big B from this sister chromatid. Big A, big B. The next one's going to have a recombination. Hope this is high enough. Big A, little b. If it's not big enough, I better put it up here. I'm afraid I'm cutting off the example. Big A, little b. This sister chromatid is also going to be recombinant, and it's going to give us a gamete like this. Little a, big B. And then this sister chromatid is going to give us a 4th gamete. Little a, little b. Just in case you can't see it, what I have down here is big A, big B. All right, so the point is that when you have a crossover, now you can get gametes where you have combined the allele that was on one homolog with an allele that was originally with the other homolog in the pair. So we had crossing over, and now we have 4 different types of gametes rather than 2 like we had before. So this is crossing over. It's a form of recombination, and it results in increased genetic diversity.